Hello, everyone. Today we're going to discuss the Leet code question or the Leet code solution for Roman numeral to integer. So for this problem, let's go ahead and make sure we understand what it's asking of us. And actually, before we do that, I want to preface this by saying that I have already performed the solution. It's already going to be pre-provided. Normally, I would prefer to code it live. However, I tried to keep it kind of clean. I refactored the code just to make it a little nicer to read. And I feel that if I were to code it live, there might be some mistakes here and there. So I just feel that it'd be best if I just explain the solution as we go and kind of use the solution that I've already submitted. That being said, let's go ahead and discuss the programming logic to solve this problem. So the first thing that we want to note is that here we have Roman numerals, right? So a Roman numeral is literally just a different type of numeric system for counting. So typically we use, 0 through 9 to count. That's our normal kind of way of counting. However, here they use a character and they match that to an integer value. And they go ahead and group those with particular rules to comprise a larger number. So for example, if I were to have, let's say, 3 i's put together, then that's no different than the integer 3, right? So we can also have this conversion here, LV and that gives us the value 58. L corresponds to 50, V corresponds to 5, and then the i's corresponds to 1. So pretty straightforward. If we were to look at this relationship, we could see that it's pretty much a dictionary. Here we have some key, which is a character, and here we have the value being a numeric, right? So you could think of this as like hash map, or you could think of this as dictionary, depending on what language you're coming from. So this seems straightforward enough in the sense that all we have to do is get the string input, iterate through each of these characters, and then add the corresponding value for that. So in this case, I corresponds to 1, so I would just add 1, add 1, add 1. In this case, it's also simple because I'm just adding each of the corresponding values for the characters. Where it gets a little bit tricky, a little bit fuzzy, is where there are certain exceptions. So for example, it mentions that for the number 4, you don't just string up 4 i's. What you do instead is you go ahead and so for 4, actually, I'm going to write it on the side. For 4, what you do is you write IV. So if you have I before V, then it actually makes 4. If you have I before X, it makes 9. So what's really going on here? The solution to these kind of tricks, and the same thing holds true for these combinations as well. If you have X before L, you really have 40. If you have X before C, then you have 90, and so forth for these two rules as well. But what's really happening here, or what's kind of like a systematic approach to evaluating these exceptions? The way we can do that is, so if I want to evaluate IV as 4, I'll individually add them. So I'll say, here's I, which is 1. So I'll add 1. And then the next value is, well, technically what I want to do is I want to check the previous value, but there's nothing behind I, so I don't really have anything to worry about. It'll become more apparent once we get to the V. So once I get to the V, I add 5. So that's the value that it corresponds to. However, I want to check if it falls into one of these exceptions, in one of these 6 exceptions. And if it does, then I want to make sure that I perform a special type of logic. So in this case, I notice that the I is before the V. So that's one of the 6 conditions that this problem is warning me about. So in that case, what I want to do is what I want to subtract the previous value. What was the previous value? I, which is 1. I want to subtract it 2 times. The reason why you want to subtract it 2 times is because the first subtraction is going to cancel the first time that you added it. So if you only subtract once, then it's going to have a net effect of 0, and it'll give me 5. So if I didn't have the second subtraction, then this would be 5, which is incorrect. I want 4. So what I'm going to do is I'm going to subtract the previous value again, and that's going to, the first one undoes the initial change that I made, and the second one actually decrements it by whatever the previous value is. Let's go ahead and apply this to IX and see if that holds true. So here I have the I, so that's 1 plus, and then here I have X, which is 10. And we notice that this falls into one of the exceptions. So what we're going to do is we're going to subtract the previous twice. So I'm going to subtract 1 and subtract 1, and that's what gives me 9. So far, so good. Let's look at a larger example. So here we could see This is the larger example that they give us. It evaluates to 1994. The way it does so is the first value is 1,000, right? And it doesn't fall into an exception because there's nothing before it, right? The previous value is, well, there's really nothing before it, so it can't fall into an exception. So I'm just going to add 1,000 plus. Then we get to the C. So for the C, I'm going to add 100 according to the logic that's provided here. But the value, the letter before it, doesn't have it fall into one of those exceptions. MC is not an exception rule, so I don't have to do anything further. But now I get to this M, I'm going to add 1,000. And then I have to check, is this one of the exceptions? CM? Yes, it is. Right, so if you have a C before M, what you really get is you get 900. So you have to subtract the C twice. So I'm going to subtract the C twice, like that. So now we're done with this M, right? So we've added its value, and we've also taken into consideration the exception. Next up is the X, right? So I'm going to go ahead and add the 10. And then next up is, so here's the X, and MX is not an exception. XC, so C is going to be 100. And I do believe X before C is an exception yet. So this right here is an exception, so I have to go ahead and subtract the previous value twice. So I'm going to subtract X twice, so minus 10, plus, and then here's I, add 1, and then here's 5, so add 5. And then we know that that falls into an exception, so we're going to subtract 1, and that's how we get 1994. So I haven't double checked this, but it should follow suit. So I hope that that makes sense. If the logic doesn't make sense, please make sure to kind of rewatch this section of it. Make sure that you really understand what's going on. Essentially, we're just adding all the values, and every time we add it, after we're done adding the corresponding value for the Roman numeral, we want to check if it falls into the exception. If it does, we want to subtract twice the previous value. That's really it. That's the whole algorithm. Now, let's go ahead and look at it in this scenario. So going back to it, here we have our dictionary, right? We have our key and values. And then here's our 6 rules that we're going to take into consideration. So for this code, notice that I created, instead of a dictionary or like a map, I ended up using a vector made of pairs, comprised of pairs. And each pair is comprised of a char, which is going to be the key, right? So, and then the integer is the value, which is going to be the value that Roman numeral corresponds to. So that's really what this is referring to. I set it as const because, you know, this doesn't change. These are hard-coded Roman numeral values. And what we're going to do is we're going to use an initializer list to go ahead and set these up. So I set up my first pair. So I is 1, B is 5, and so forth until I get to M, which is 1,000. Right. So this looks pretty straightforward so far. And not to worry, I'm going to go ahead and add this code in the description because I don't want you to focus on kind of copying down every piece of code, just kind of looking at it, understanding it, making sure you kind of makes sense. And also as a reminder, I did refactor this a little bit. So if you go ahead and try this problem and it doesn't look the same, that's totally normal. You know, this my first attempt at it did not look the same. I actually tried a hash map originally, but I didn't, or I tried a map, an ordered map originally, but I ran into some issues just because instead of it retaining this order, IVX, LCDM, I ended up getting these in alphabetical order. So the C would come first, and there's kind of like issues. I wasn't really a big fan of using the map, but that's okay. You could do it with the map, but I just didn't end up going that route this time. Anyways, so going back to it, so now that I've set up my dictionary, I also set up a really convenient function to get the key to get the value given a key. So if I were to give this function the letter M, it would spit out 1,000. If I were to give it C, it would spit out 100. If I were to give it X, it would spit out 10. Actually, let's just see that really quickly in action just to show you that how it's working. So all we're going to do is we're going to spit out get Roman numeral value, and we'll put in a character in there like X, and it should give me 10, right? So there it is. It's going to print it out. So this is just a convenient function to kind of do that. The way we do this is we have this function accept the key, which is going to be the Roman numeral, and then we have it also accept this this vector of pairs that we created. Notice by default, I assigned it a default value, which was this specific data structure. That's why there's the 2 colon signs, or the 2 colons before the name. This just means it's part of the global scope, so it knows what to target. And that's because I used kind of the same name here. We don't have to worry about this. This is more like C++ idiosyncrasies, but just know that the reason why I set it as default is so that whenever I call this function, I don't have to worry about passing in this how should I say this vector of pairs. All I need to pass in is a key, so it looks kind of cleaner. What I'm going to do is I'm going to iterate through my Roman numerals, and if I find my key, which I am going to, because this problem assures me that it's going to give me a valid Roman numeral, then it's going to give me the value, and then I'll go ahead and spit that value right back up. Now here's an example Roman numeral, which is the test case, the third test case on Leet code. Initially, we're going to have our value set to 0. So set to 0 just because we haven't started adding anything. And notice our previous value is going to also be set to nothing. We're set to some not null value, but just set to some kind of useless flag, right? I don't know if that's the right term, but this is just so that we know it doesn't trigger any of these conditions initially. What we're going to do is we're going to iterate through the string. And this is the part that's really simple. So once we start iterating through the string, through the Roman numeral, what we're going to do is we're going to take each letter and we're going to add the value of the Roman numeral character to our integer, right? To our sum. Right? I know I called it value, but just to our sum. So this part's very straightforward. We're just adding it. Now, if there were no exceptions, that's all we would have to do. Wouldn't get any more complicated than that. However, we do have six exceptions to consider, and these are the exceptions. So these are the 6 exceptions. 6 exceptions. There we go. And that's that if our letter is V or X and the previous is I, then that's an exception. If our letter is L or C and our previous letter is X, or if our letter is D or M and our previous letter is C, then these are any of the 6 conditions. So if notice right here, if any of the exceptions trigger, then the solution is going to be the same. What we want to do is we want to remove twice the previous value. So whatever the previous value is, we call that function to get whatever its value is. So notice if the previous value was I, this would resolve to 1. If this was previous was X, this would resolve to 10 and so forth. We kind of saw how that worked with the whole given a key, given a key, get the value. But notice we're going to go ahead and multiply that by 2. And we're using the compound assignment operator, right, minus equals, so that we can subtract 2 from the value. So essentially, this is no different from saying, subtract 2 times the value. I just kind of wrote it a little bit differently to kind of make it a little bit cleaner. And once again, what's the logic behind this? Why do we subtract 2 times the value? It's because we, number 1, need to undo the initial addition that we did. And number 2, we need to decrement it by that previous value. And that's really what's going on there. And at the end of your loop, make sure to go ahead and update what your previous value is. Right? Your current value for this iteration becomes the previous value for the next iteration. Right? So that's just a quick update. It'll go ahead and iterate through the entire string and add up to the correct value and decrement wherever the exceptions are caught. And then afterwards, it's going to go ahead and print out the value. So if I run this, notice it's going to give me 1994, which is the test case we were looking for. So I hope that this made sense. Please let me know if you have any questions in the chat. Once again, I do apologize that I didn't go ahead and live code this for the video. And that's really just because, as you can see, it's already kind of a little bit of a lengthier video, and coding it from scratch, it's definitely doable. I could definitely do it probably within maybe like 20 minutes or so, but I know I'm going to make some syntax errors here. And if I get a little nervous, I'm probably more likely to make some syntax errors. So that being said, thank you so much for watching. The code is going to be in the description. I hope you enjoyed this video. Please like, share, and subscribe if you did. And I hope I can see you soon for some more coding solutions.